Alright, so in this video we're going to be looking at simplifying surds. Now first of all you'll see that I've written this list of numbers. Now everyone should be very familiar with this list of numbers. They're square numbers. You've got to have them memorised. I don't mind if you write it down on your piece of paper over the next week or so, but make sure you have that memorised, particularly by the time you go into the test, whenever that might be. Okay, so these are the 5 surds that we're going to simplify. Some of them actually aren't surds, which you'll see in a moment. Okay, this first one, really simple. The square root of 81. Now you should know that the square root means the number that when multiplied by itself makes 81. And the number that when multiplied by itself makes 81 is 9. Okay, so this is technically not a surd because we can easily turn it from a square root into an integer, into a whole number. Looking at this next one here, this is also not a surd because you should all be able to look at that and say, oh, I know the square root of 9. The square root of 9 is 3. 3 times 3 is 9. Okay. Drawing a big line here because this stuff is new. You've never really seen it before and it can get a bit tricky. The square root of 12. Now if I look at my list of square numbers, it's not there. So I can't just simplify it like I did with these two. What I can do, however, which is really quite clever, is break 12 up. Something times something equals 12. Now I really want to find something in 12 that also appears in this list. For instance, 12 is equal to 4 times 3. So the square root of 12 is exactly the same as the square root of 4 times 3, because 4 times 3 and 12 are the same. Now that I've done that, you should be able to see that the 4 is a square number right there. Now, a really cool thing that we can do here is grab this 4 and take the square root of it and move it outside of the square root symbol. So it's going to look like this now. The 4 moves outside of the square root, and when it moves outside of the square root, it becomes the square root of 4. It becomes 2. Root 3. Okay, so just slowing it down. That 4 moved out of here. When it moved out, it became 2, because 2 is the square root of 4. And then what are we left over with? We're left over with a 3. So I've simplified root 12 to 2 root 3. Okay, let's try another one. Root 50. Now we need to come up with a way to break 50 up to something times something makes 50. And we need one of those things that we break it up into to be something from this list. Now I could break it up into 5 times 10. But there's a problem there because 5 and 10 are not on my list. So breaking it up into 5 and 10 is useless. I can break it up in a different way, however, that is going to help me. 25 times 2. So 25 times 2 is the same as 50. Now one of those numbers is on my list, 25. So I can take that 25 and move it outside of the square root. And when I do move it outside, we find the square root of 25, which is 5. So 25 moves out and becomes 5. Now what's left over? The square root of 2. Okay, we're doing pretty well here so far. Last one, the square root of 300. Now here's a really big number, so you need to have a little bit of a think about it. The square root of 300. Now if you look through your list, one should jump out at you here. Big number, big number. What about 100? So the square root of 300 is the same as the square root of 100 times 3. Now we can take 100 and move it outside of the square root. Now the square root of 100 is 10. Root, and what's left over? 3. Okay, so there's 3 examples of where we've simplified surds. Now one last point before we finish off, you'll get reminded of this in future videos. 2 root 3 actually means 2 times root 3. This actually means 5 times root 2, and this actually means 10 times root 3. There's a multiplication sign there, but we just don't put it in. It's nice and neat if we don't bother putting a multiplication sign in there. Okay, there's simplifying surds. We might run through some other ones that are a little trickier in a